Good morning, Dragons. It's Ms. Mortensen coming to you on Wednesday, March 25th with our math lesson for today. And today we are going to continue using comparison bars to study multiplicative comparisons. And today we're going to ask ourselves, what is the most efficient way to attack a problem when we have multiplicative comparisons? Do we want to multiply or divide? Now, because they are inverse operations, we can usually use either one, but we want to find the most efficient way to solve the problem. So we're going to come up with some tips and tricks to help you do that. Okay, so please take out your sparkly notebooks and your colored pencils and go ahead and write page 19, multiplicative comparisons, multiply or divide, ? And if you need some time, go ahead and pause this video so that you can get caught up with the class. Great. Welcome back. Now we are going to draw a large star and we're going to write large part unknown. So sometimes the large quantity of the problem is unknown, and we want to find the most efficient way to solve that problem using comparison bars and the different operations. Okay, so now I'm going to go in and write our example problem. So go ahead and write example and choose a color for your example. So write, Soraya ran 4 laps during PE. Oh, I miss watching you guys do PE with Coach. I hope you're doing PE at home, getting out there and running, doing your exercises and all of that. Okay, next, Sunny ran 5 times as many laps as Soraya. How many laps did Sunny run? So we have a known quantity. Soraya ran 4 laps. We have an unknown quantity. We know that Sunny ran 5 times as many laps, but we don't know how many laps Sunny actually ran. So now we are going to do our comparison bars to find the answer. This is a visual representation of this algebraic problem, because when we have an unknown quantity, then we can solve that using algebra. So for my comparison bars, I chose a teal pencil for Soraya because she's often wearing a teal colored sweatshirt to school. And I wrote Soraya's name as my label, and then I did a bar chart for her with the number 4 because we know that she ran 4 laps. So go ahead and do that. Then I picked orange for Sunny because Sunny has her orange jacket that she frequently wears to school. And I drew 5 bars for Sunny because she did 5 times as many laps as Soraya. So she did as many as Soraya, and then she doubled it, she tripled it, she did 4 times as many and 5 times as many. So we have 4, 4, 4, 4, 4, 5 times because she did 5 times as much. If you need to pause to make your comparison bars, go ahead and do that. As you can see from my comparison bars, I used the lines in my notebook to make my lines as straight as possible. And although my comparison bar for Sunny, my boxes aren't exactly equal, I tried to make them as equal as possible. So neatness counts. Okay, you want to make these nice and neat so that they are a neat visual representation of the problem. Now, we know that Soraya ran 4 laps, so we're going to write that down. Now we know that Sunny did 5 times as many, so times 5. And then we have our unknown quantity here, And we don't want to do L for laps because a lowercase l in algebra looks like a 1, and we know that 4 times 5 does not equal 1. So instead of L for laps, I'm going to use the variable R for run. But really, does the variable matter in the end? Not really, okay, as long as it looks like a lowercase letter. Now, 4 times 5 is going to equal the unknown quantity. And since we know our multiplication facts, we know that 4 times 5 equals 20. So, in the end, if Sunny ran 5 times as many laps as Soraya's 4 laps, then Sunny ran 20 laps. We'd write that, and we need to make sure that we write the numerical value and that we label it. And then we should box our answer, get into good mathematical habits. So then we can also say, therefore, Sunny ran 20 laps. Okay, if you need to pause right now to get caught up, go ahead and do so. But you can see that this problem, the large part was unknown. The 20 laps was our unknown number. So multiplication for our comparison bars was probably the most efficient way to attack this problem. Okay, good. Okay, welcome back. Go ahead and skip a line or two and change colors. You're going to make your large star and you're going to say small part unknown. So our first example had the large part unknown, but sometimes we have word problems where the smaller sections of the problem are unknown, or just one small part is unknown. And so we're going to use our comparison bars to solve that problem, and we're going to pick a variable to represent that unknown small part. So in this example, we're going to write our problem here. So in our example, Giorgio's family purchased a large pizza for $24. This cost 3 times as much as a small pizza. How much does a small pizza cost? So we know that the small pizza is going to cost less than a large pizza. Any of us who've ever bought anything know that the smaller size is almost always much less than the larger size. So we have our large part as our known quantity, $24. We know that this was 3 times as much as what a small pizza would be. So our small part is unknown. So now we can represent this problem as a comparison bar. So we're going to change colors, and so for Giorgio, I used green. So Giorgio / the large pizza was 3 times as much as the small pizza. Now, we wouldn't have these numbers in here at this point, okay? We would just have 3 boxes for Giorgio. So we would write large pizza, Giorgio, large pizza, and we'd have a box, and then we'd have our small pizza here, and it would be 1/3 the size. And so that almost looks like half the size, so we'll do this. Okay, so here we have a section, a section, and a section, and here we have a different section, okay? Now, we'll set up this problem as a division problem. When we have a small part unknown, division is typically the most efficient way to attack the problem. So we have a problem like this. $24 divided by 3, because it's 3 times less for the small pizza, is going to equal S. And I chose the variable S for small, because I want to know the cost of the small pizza. And now I solved this problem. And because I know my division facts, I know that 24 divided by 3 is going to equal 8. So S, small pizza equals 8. Therefore, $8 is my answer. And when I have the dollar sign, that is my label. So I don't have to write the word dollars, but I can. So I can choose either the dollar sign and 8. This would be my label, and this is my numeric value. Or I could write 8 and the word dollars, either one. Then to finish the problem, I go back to my comparison bars, and I know the small pizza costs $8. And if Giorgio's costs 3 times as much for the large pizza, then I have $8 plus $8, which equals 16. That's 2 times as much. Plus $8, 16 plus 8 equals $24, or 3 times 8 equals $24. So I know that that makes sense. So not always, but typically, if the large part is unknown, multiplication is frequently your best bet. And if your small part is unknown in a problem, division is typically your best bet. But either way, you can represent the problem as multiplicative comparison with a comparison bar. So I hope this helps you understand comparisons a little bit better, and I hope that this will help you with your assignment today. In our next video, we are going to look at page 147 from California Math Expressions, Volume 1, and we're going to work through some of the problems on page 147 together. Then you're going to continue on with page 148 and see if you can do some of those problems on your own. Again, remember, try to make your comparison bars as straight as possible and as even as possible. Okay, great. Thank you. I hope that you enjoyed this lesson. If you have any questions, please call or text me at 805-245-3639, or you can email me at mmortensen@syvcs.org. Thanks, guys. Enjoy.